Okay, so we are now on the prereq section 5 for trig, which happens to be algebraic expressions. So let's take a look at some algebraic expressions. We have some polynomials, and what I want you to realize here with the polynomials is that a polynomial is some variable x and an exponent as well, and I have it to the nth power because it could be x to the 8th, x to the 10th, x to the 100th, and it goes down. And notice how every single time it's going down 1. So like x to the 7th would be x to the 7 minus 1, which is 6, and x to the 7 minus 2, which is x to the 5th. So it's going down each time, and you kind of want to arrange your polynomials in order the entire way down, if at all possible. So over here we have an example of a polynomial, which is just something to keep in mind here. So here's an example of a polynomial. Notice how it goes down each time, right? We have x to the 4th, x to the 3rd, x squared, x, and then no x's. So just something else to keep in mind.
You think you're too cool for school?
So degree and leading coefficients of polynomials. The leading coefficient is the number out in front of the first variable. So the very first number, but keep in mind, as I just showed you on the last thing right here, alright, it has to go in order. So notice that the variables all go down in order, the degrees go down in order. So in this right here, because it's in order, this 3 is the leading coefficient. So it's just something to keep in mind. It's the number that's out in front. So the leading coefficient is the number out in front, and the leading degree is the number above the first variable. Okay, and that's what I showed you. So the leading degree is the number with the first variable, the highest coefficient there. So adding and subtracting polynomials, here is your first example for you with adding and subtracting polynomials. Let me try to get this out of the way here for you as far as I can get it. But basically, when you're adding and subtracting polynomials, you are adding and subtracting things that are alike. So in this circumstance, this x cubed. Are there any other x cubes anywhere else? Well, right here they are. There's 4x's cubed, so I can combine those together is the point that we're getting at here. And that's what I'm going to do first. I'm going to combine like terms. So if I have 1 x cubed and 4 x's cubed, when I add them together, I end up with 5 x's cubed. Well, right here I notice that I have a x squared and another x squared over here. I have 2 of them, and I have negative 5 of them. So 2 and negative 5, when you add those together, is a negative 3x squared. Moving on to the x's. I have an x over here. Nope, actually I don't. Okay, so basically what I'm saying is I have negative 5 x's and I have absolutely no other x's. So what that means is, what's negative 5 x's plus 0 x's? That means I have just the negative 5 x's because there is no x's over there. There's 0 x's, so when you add those you get a negative 5x. And then all that's left are the numbers. I have a 7 and a 3, and 7 plus 3 happens to be 10. And there's your answer. So once again, adding and subtracting polynomials is just adding and subtracting like terms, is basically what we're talking about here. Down here at the subtraction problem, it is minus this entire thing, and that's why I have that in parentheses, which means that negative could be distributed through to every single item using the distributive property if we wanted it to. So that is just something else to keep in mind. So when doing this problem, this is exactly what I'm going to do for this one. I'm going to keep this all the same right here. And then it's minus the first item. Well, minus, so a negative times a 4x cubed is minus 4x cubed. A negative times a negative 5x squared, and negative times a negative is a positive, so that becomes a positive 5x squared. And a negative times a 3 will give you a negative 3. Now with all of these, I can now do exactly what I did up here, and I can add them together. So I have 1x cubed and negative 4x's cubed. So 1 plus negative 4 is negative 3x's cubed. I have 2x's squared and 5x's squared. So 2 of them plus 5 of them is 7 of them. I have a negative 5x, but as we stated before, there is no x's. So there is no x's. Negative 5 of them minus none of them is still going to be negative 5. So we have negative 5 x's. And 7 and a negative 3. 7 minus 3 is positive 4. And there's your answer for example 2.
I'm very important. I have
Multiplying polynomials now. Well, multiplying polynomials is kind of exactly what you did before. And that was in Algebra 2 when you were talking about foiling, the first, outer, inner, last, and that's exactly what you're doing here. We're taking these terms and multiplying them together. So for example, the first terms, 4x times 3x. 4x times 3x. Well, 4 times 3 is 12. X times x is x squared. 4x times a negative 2. That is 4x times negative 2. 4 times negative 2 is negative 8. So it's a negative 8x. And then I move to the inner terms here. So 5 times 3x. 5 times 3 is 15. So it's a positive 15x. And 5 times negative 2 is a negative 10. So now all I need to do is combine my like terms, just like we did before with adding polynomials, just the last example. And when doing that, are there any other x squareds? Nope. Are there any other x's? Yes, there are. We have negative 8 of them, and we have 15 of them. So I drop down that 12x squared, and I need to combine these two x's together. I got negative 8 of them and 15 of them. So when I add them together, I have positive 7x. And bring down that negative 10, I have 7x minus 10. And there's your answer. Now the foiling can be done, but obviously there's not a first, outer, inner, last here anymore. Okay, now you have something a little more intense. There's more areas to go, so it's all about keeping track of what lines up with what when you are multiplying. So I'm going to start with the outside. And an x squared times a 2x cubed. Well, 1 times 2 is 2. And x squared and x cubed, well, what are you supposed to do with exponents? You add them, right, when you're multiplying. So 2 plus 3, that's how we get the 5. Then x squared times the 3x. Well, 1 times 3 is 3. X squared and an x. Well, that's a 1. The exponent there is like a 1. So when you add them, 2 plus 1 is 3. And I have x squared times a negative 1, so x squared times negative 1 is just a negative x squared. And I move on to the middle term now. 5x times 2x cubed. Well, 5 times 2 is a positive 10. X to the first power, which is what that is, an x cubed. Remember, when you multiply with exponents, you're actually adding the exponents together. So 1 and 3 is 4. 5x times the 3x. 5 times 3 is a positive 15. X times x is x squared. And 5x times a negative 1 is a negative 5x. Then the last term, a negative 4 times 2x cubed. Well, negative 4 times 2 is negative 8x cubed. Negative 4 times 3x, that is negative 12x. A negative 4 times a negative 1 is a positive 4. So, now that I've multiplied everything through, now I got a whole bunch of combined and like terms. So I start in the beginning. There are no other 2x's to the fifth. Alright, next highest exponent that I see is the x to the fourth. Are there any other x to the fourths? Nope. So I bring that down as plus 10x to the fourth. Next would be a cube. Do you see any cubes? Well, here's a cube. That's 3 of them. Here's another one, negative 8 of them. So 3 of them and negative 8 of them, when you add them together, is negative 5 x's cubed. So next up is x squareds. So I have a negative x squared and a 15x squared. So negative 1 and positive 15, when you add them together, will give you a positive 14x squared. Next up would just be x's. I have negative 5 of them and negative 12 of them. That means I have negative 17 x's. And all that's left that I didn't cross out is a positive 4. And there is your final answer with all your terms multiplied together. And when we come back, we will continue on in section the prerequisite 5 in Algebra 3 Trig on algebraic expressions.